Hey everyone, welcome to Professor Long's Lectures in Anatomy and Physiology. I'm Professor Bob Long. I'll be your instructor this semester. As you guys know, we're in the coronavirus or COVID-19 shutdown. Literally during the spring break, almost overnight, we had to go from teaching face-to-face to online. I'm traditionally a face-to-face teacher. I'm not a strong proponent of online teaching for anatomy and physiology. But, you know, we can't change the wind, we can only adjust our sails, and adjust our sails we are. So, this series of videos and this YouTube channel is established solely so that I can deliver instruction to the students who are enrolled in my Human Anatomy and Physiology course at Del Mar College. If anyone else out there in YouTube land finds these videos helpful, awesome. Use them, whatever advantage you can get from them, great. If you have some feedback, some critiques or criticism, by all means, shoot me a message. Anyway, these videos are being done rather crudely. I'm not a real online guy. I'm not real technologically savvy. As I like to say, I'm not that smart, so I have to simplify things. So these videos are being shot in my dining room with a cell phone and my laptop, and I'm doing the best I can with what I got. There won't be a lot of fancy editing. If you hear any background noise, I have 2 teenagers and a dog here at the house. So, you know, we got to deal with what we got to deal with. Anyway, so this series of lectures is going to be for my 2402 or Human Anatomy and Physiology 2 course, starting in the summer of 2020. Now, one of the things that I utilize in my course for my lecturing is a note set, something that I write and publish. I sell it through the bookstores. It's roughly $12. We make nothing off of it. If I do make any money off it, it goes to donations for scholarships. My wife and I have a scholarship that we give money to a student every year. So if you have this, great. If you don't have this, you can purchase one at one of the 2 bookstores, the Del Mar College bookstore on campus or Nebo, which is next door to Del Mar College. They usually have them in stock. They're pretty cheap. I don't know about the campus bookstore, but I do know about Nebo. We'll drop ship one for you and email it or mail it to you if you need one. Also, in addition to this, I'm going to be posting some worksheets with every video that I give. The worksheets will be derived from the note set and the notes that I provide and go along with the lectures. The material I'm going to present is going to be designed or designated for the students enrolled in my course. If you tried to cover everything in every chapter in anatomy and physiology, we could have an 18-semester course. There's so much information going on in the human body, so much to learn and know that there's no possible way that we could cover it all. Since this is a sophomore level course, this is an introductory level of anatomy and physiology, and that's going to be my approach. An overwhelming majority of my students are destined for health-related careers, what we call the allied health sciences. Nursing, radiology tech, surgical tech, occupational therapy assistant, PT, physical therapy assistant, respiratory therapy, dental hygiene, dental assisting, sonography, echocardiography. We have a myriad of programs, medical lab tech, EMT, paramedic, and some kinesiology majors. For 20 years now, I've been polling my classes, and usually 98 to 100% of my students are destined for careers in the allied health sciences. Because I have experience in the allied health sciences as well as teaching this stuff in a research background, I'm going to present it in a manner that's directed at meeting the needs of the students for those programs. We cannot cover everything, so some of the lectures I'm going to provide are going to be abbreviated. They're going to be designed so that you form a solid foundation on which to build more information. Some people, I know because I was a student, I had instructors that went over every word and every paragraph and every page of the textbook and did 1,000 PowerPoints, and it was just really an alphabet soup of information. And you couldn't keep up writing everything down. It was literally like memorizing the encyclopedia. And you can't learn from that, especially at the ground level. And so we're going to be presenting things so that we develop a fundamental basis, a foundation of understanding of the major principles. We'll add some level of detail. The level of detail that other instructors go into in various topics may differ. So, you know, again, this is designed for my students. I hope you find it helpful. Later on, as we continue to build this foundation and set the studs and the walls, we'll be able to do things like add details, hanging pictures, and, you know, nice decorations. But if the foundation of a building is not set, all the details come crumbling down. So I'm a fundamentals guy, and this is the way we're going to present it. Now, this first lecture is actually not even in my note set anywhere. This is a step back from what we do in Part 1 A&P, where we finish the semester. So this is going to be a review of some concepts that we covered in Part 1, but these concepts are so vital and fundamental for your understanding for both the rest of A&P 2, this entire semester of courses, but also for your future courses in the Allied Health Sciences. So let me step back for a moment and just provide this lecture to set the foundation or the basis for a number of things that we're going to do for the rest of the semester. Hope you enjoy this. Follow along. So at the end of Part 1 A&P, one of the things that we were doing is that we were studying the nervous system. And we went over the organization of the nervous system. If you recall, we have the central nervous system, or CNS, which is largely the brain and spinal cord. Okay? And this is where we do the highest level of information processing, decision making. But there's so many structures and areas and nuclei and centers within the brain that control a lot of our homeostatic functions, our physiology, and control many other systems, that the CNS is really doing a lot of decision making, some of it at a very subconscious or below the conscious awareness level. But nonetheless, it's almost all directed here. There are some reflexes that can bypass this. We're not going to talk about those motor reflexes. Now, we also had the peripheral nervous system, or the PNS. The peripheral nervous system, we stated, were the 12 pairs of cranial nerves, the 31 pairs of spinal nerves, and all nerve branches, all the way out to your arm, like the radial and ulnar nerve. That's all peripheral nervous system, that out in the periphery. Your central vision is the vision right in front of you. Your peripheral vision is the vision off to the side. Central nervous system, peripheral nervous system. Now, the peripheral nervous system has two major subdivisions, okay? Hopefully you can read my handwriting. If not, well, I'm sorry. I'm real old school. This is how I teach. The two major subdivisions are going to be the afferent nervous system, which is purely sensory. It's going to carry sensory information into the CNS. Out in the periphery, we have these specialized cells. Anytime you see me do this little R with a circle around it, what it means to me in my shorthand is a receptor cell or a receptor. Out in the periphery, we have some kind of receptor cell. In the special senses, there's a unique receptor cell that can release neurotransmitter on a cell that goes into our spinal cord, has the soma and the dorsal root ganglion. And then that's going to carry information up to the brain. We're going to think about that information. That's all sensory input. In the special senses, you're going to learn when we start these lectures on the special sensory system, there's an extra neuron called a receptor cell. Now, in the general senses, the first order neuron is that receptor cell. There's a minor difference in that we have an extra cell in the special senses, in the general senses we don't. But either way, we're going to take sensory information into the spinal cord, release neurotransmitter, another neuron, the second order neuron, will carry that up to the thalamus, and then from the thalamus, we'll have a third order neuron which communicates somewhere in the brain. Now that would be for touch, temperature, pain, some of our general senses, but many of the sensory pathways follow a similar setup. Now, one of the things that we're going to focus on this semester, starting off with, is this out here, the sensory receptors, or the sensory system, the general and the special senses. Now, by the way, as I do these, I know it's cutting off my head and I'm stepping in and out of the screen. I only have so much space in the space that I have here. So just bear with it. Ultimately, what's on the board is what's important to you. So now, for the afferent division, we're pretty much kind of done with that as far as our review. When it comes to the first lecture test, we're going to focus on these sensory neurons and the special and general senses. But before we get there, I want to review this. The second major subdivision of the peripheral nervous system is going to be called the efferent nervous system. So I'll put a number 2 over here for the two major divisions of the PNS. The first one is afferent. The second one is going to be efferent. Efferent, F comes from exit, and ferre means to carry. It's going to carry motor commands away from the central nervous system out to the effectors, which are going to give us the desired effects, which are going to be muscle cells. So this is always motor, and we call them motor commands or motor output. Now, when a neuron comes out of the spinal cord or one of the cranial nerves, it's going to synapse on an effector. Now, the efferent nervous system itself has two subdivisions. One of those subdivisions is called the somatic nervous system. I'm going to abbreviate nervous system as NS. The other one is called the autonomic nervous system. Now, we have three different types of effectors that we can be controlling or having give us some motor responses. One of them is skeletal muscle. Well, skeletal muscle is controlled by the somatic nervous system. So, for all of our skeletal muscle, this is what we often call voluntary. Somewhere in our brain, at some level of consciousness, we have to make the decision to move something. It might be at a low level of consciousness, but it's a conscious decision. And the somatic nervous system is always going to synapse on skeletal muscle and cause skeletal muscle to fire. Now, the autonomic nervous system is going to control what we call visceral or smooth muscle plus cardiac muscle. As you should know, smooth muscle is found in the walls of our viscera, our guts, our digestive tract, and are going to help propel things. When you swallow something, it's going to fall out the other end, whether you like it or not. What's going to move it through the tract is going to be visceral or smooth muscle. Smooth muscle is found in the walls of blood vessels. It can constrict, slowing down blood flow through that vessel, or dilate, allowing greater flow through the vessel. That's how we will adjust blood flow from one area of the body to the other to meet the body's energy demands. It's found in the walls of the respiratory tree. It can constrict and dilate the air passages. If we constrict the air passageways, then less air flows through. That's what happens at night. We start wheezing and things. When we need more airflow for more oxygen, then it will dilate and allow more air into your lungs. Okay, so we find it in the walls of a lot of our digestive tract and viscera, and the walls of the respiratory tract, and the walls of the reproductive and urinary tract as well. Helping produce urine, controlling blood flow to the kidneys for filtering and urine formation. We also find smooth muscle in the walls of glands, salivary glands, sweat glands, and other things. So, all of these glands, all of this smooth muscle, and our cardiac muscle are also going to be functioning at the same time as the skeletal muscle. The autonomic nervous system is always on with the somatic nervous system. The difference is, what I need to happen in different parts of the body here is going to be dependent upon the level of activity of the skeletal muscle. When skeletal muscle is in a high level of activity, meaning we're running, we're exercising, we're freaking out, stressing, having to fight for your life, run from a dog chasing you. When we have high levels of skeletal muscle activity, our skeletal muscle is going to burn a tremendous amount of oxygen and glucose. So I need to adjust blood flow to my muscles and increase it. I need to decrease blood flow to those areas that aren't functioning at a high level. When we're stressed, we don't need to be worried about going to the restroom or reproducing or digesting. So we shut down or decrease blood flow to those areas and shift a large part of the blood to our heart, our lungs, our muscles, and our brain so that we can get out of a sticky situation. Once the stressor or and there's good stress like exercise, but once the stressor is removed, then we can switch back to decreasing blood flow to the muscle, to skeletal muscle and the heart and the lungs, because we're going to lower our level of activity. We don't need as much energy. And then we can dilate blood vessels and increase the activity of all the visceral muscle, digesting food, making waste, cleaning the blood, getting ready to reproduce, and many other things. Because the autonomic nervous system has to adjust these to meet the needs of the skeletal muscle, the somatic nervous system, there are two subdivisions for for the autonomic nervous system. And those two subdivisions are really what we're focused on. And you should know these from part one. One is called the sympathetic nervous system. The other one is called the parasympathetic. And I'm going to run out of room on this little board, so I'm going to just write parasymp for parasympathetic nervous system. Both of these are controlling visceral and cardiac muscle. So, when it comes to the efferent divisions, one of the things that's important is, as I send motor commands out, those motor commands are going to go from the efferent nervous system to both the somatic and the autonomic nervous system. A lot of people make the mistake that it's one or the other, and it's not. It's somatic and autonomic are firing together. But depending on the level of activity of the somatic nervous system, the autonomic will trigger to sympathetic or parasympathetic. If skeletal muscle is in a high level of activity, we're under sympathetic nervous system, sympathetic activation in the autonomic nervous system. When skeletal muscle shuts down, we switch over to parasympathetic, and that's going to have a huge effect on the adjustments here. So, I'm going to try to wrap this video up in a minute. I hope you have this kind of picture in mind. Now, eventually what we're going to get to is this stuff for our first lecture test. But prior to that, I want to review the sympathetic and parasympathetic. And the reason I make a big deal of this, and I always do this at the beginning of part 2, is because we hit the nervous system at the very end of part 1. Everything's hurried, everything's rushed. But this autonomic nervous system part is going to come back when we do not only our sensory physiology, but when we do cardiovascular, respiratory, digestion, urinary, reproduction. All the other systems are going to keep coming back to this. You absolutely have to know the autonomic nervous system, at least the fundamentals. There's some details you can add later. So, having gotten this out, let me erase the board, and I'm going to simplify the autonomic nervous system so that you don't have to memorize lists and lists and lists of stuff. You can literally think of a simple example and be able to answer most questions. Pardon my back, but this is what I got to work with. So, when it comes to the autonomic nervous system, sympathetic and parasympathetic, I have a really simple concept that works to help understand it. And explains a lot of what's going to happen in the body. When I was a student, we were struggling with this, and a lab partner, one of my classmates and I, kind of came up on this idea and kept expanding it and expanding it. And a lot of people went, "Oh my God, that's so easy!" So I'm going to share it with my students. It requires that you think of an old school steam engine. So if you look at old cowboy movies or westerns, they have these old trains that have this big metal bar that shoot a lot of smoke out. It's not really smoke, it was steam that they were shooting out. The way that these old engines worked was that there was a large tank inside filled with water, like a boiler. And then coming out of this tank were some big long tubes that came up that had an opening up here. Sitting inside these tubes were cylinders that completely filled most of the tube but could slide in them. These cylinders were attached to some metal things which were eventually attached to the wheel. Now, in this big boiler, there was water. In order to get the train going, you had to have a fire. So, they had a large fire underneath here that would boil the water and create steam. As you know, steam rises, and the steam would rise and push up on these pistons or cylinders. Kind of like the way a car works now, only they use combustion, small explosions with gasoline. Here we're using steam. So, as these pistons went up with the pressure, if the piston rose above the opening, all that pressure would be released. Come out shooting in a bolt of steam, and the piston would drop, and the other piston would go up, and they would continue to rise like this. So that's the sound you hear when you hear those old choo-choo trains chugging along. And as the pistons went up and down, they made the wheels go around, and because of this bar, the faster that the pistons went up and down, the faster the train went. In order to have any kind of fire, you must have a carbon source. Well, if you ever had an old choo-choo train like I did as a kid, the first car behind the train was filled with coal. Well, in our body, that's not coal. For us, it's glucose or sugar, what we call a simple sugar. And the organ that stores a lot of these sugars in our body would be liver, and then there's some of this stuff in skeletal muscle. When I have a whole bunch of glucose stuck together, it's actually in the form that we call glycogen. This is how we're going to store sugar. So the liver is filled with glycogen, just like this car was filled with coal. If I need the train to go faster, I need a hotter fire. In order to have a fire, I need always two things. One is a source of carbon, glucose, that's C6H12O6, 6 carbons, 12 hydrogens, and 6 oxygens. But you can't burn a carbon source without oxygen also. So we also need a source of oxygen. Well, that invites in our respiratory system here. Our lungs are going to take oxygen out of the atmosphere and bring it into our body, into our bloodstream. And the liver is going to dump glucose or sugar by breaking down glycogen. We break the glycogen into glucose, we feed it into the engine, and with the carbon source plus oxygen, we're going to get out of this energy. We'll get some carbon dioxide and some water, like the steam. The carbon dioxide would be the stuff that we exhale, get out through the respiratory system. So this is a rather simple setup. One other major organ system is involved here. In these old trains, there was a guy called a fireman. There was the train driver or engineer. He had to calculate times and distances and how much supplies it took and make sure that he made it in time, when to hit the brakes, when to stop feeding the engine, and all of that. The other guy was called the fireman. And what the fireman did was the fireman stood here and he had a shovel for the glucose and he had a thing called a bellows. I don't know if you've ever seen a bellows, but they kind of look like this. And they're near fireplaces and they have a little accordion in here. When you pull them in and out, it will suck air in and blow air out. Instead of sticking your face in your fireplace going to get a fire hotter, you used a bellows to pump air. Well, that's kind of what the fireman did. The fireman was shoveling glucose, shoveling coal into the fire, and blowing air across it to make the fire hotter. The fireman represents your heart. The actual engine itself represents your brain plus skeletal muscle. So, knowing all of this, I'm going to erase some of this stuff, okay? But knowing all of this, what we know is that we have to release glucose, sugar, from the liver, feed it into the fire. We have to have oxygen coming in, and it is the heart that's shoveling oxygen and glucose into the engine if the engine needs to go faster. If the engine needs to slow down, all I have to do is stop feeding it, and it will naturally burn up its energy, and the train will start slowing. Well, this is an outstanding example of the sympathetic nervous system. The sympathetic nervous system, from the autonomic nervous system, is known as the fight or flight system. It is active during stress. So when we're stressed out, your mind is going 90 miles an hour. You can't sit still. You tap your feet. You tap the table. You're moving your legs under the table. You're nervous. You're shaking. You're pacing around the house or whatever it is. When the brain and skeletal muscle are under sympathetic fight or flight activation, then they're going to be going 90 miles an hour. Then we can figure out just from this simple concept, here's what needs to happen. I need to increase heart rate and blood pressure. The heart will beat faster and squeeze harder to get more blood through the vessels. I'm going to increase my breathing rate and depth of breathing. I'm going to increase respiration. I need to start blowing a lot of oxygen in, getting the carbon dioxide out, so I'm going to breathe faster and harder. I'm going to increase what's called glycogenolysis. Now, this is a term we're going to learn later in the semester, but we're going to break down glycogen to release glucose. So we're going to increase the amount of sugar in our blood so that we can pump it to our muscles in our brain. We're going to increase blood vessel diameter to the brain, the heart, the lungs, and skeletal muscle. Sorry, my penmanship's getting a little wacky there, and I'm going to decrease blood vessel diameter to the urinary, digestive, and reproductive systems. Sorry, I'm running out of room. So, I'm also going to do a number of other things, but this gives you the basic idea. Here's kind of the concept that I use. This is the general idea. If I use the diaphragm to separate the thoracic and the abdominal pelvic cavities, everything in the chest is going to increase. Heart rate, breathing rate, blood pressure, the force of contraction, the blood vessel diameter here, and to my brain, and to my skeletal muscles. Everything below the diaphragm I'm going to decrease. I'm going to decrease urinary and waste and reproductive and digestive function. So my stomach peristalsis will slow. The ability to form urine and waste will slow. The desire to reproduce and the secretions will go away. So ultimately, if you think of the diaphragm, everything up here increases under sympathetic. Everything else, like going to the restroom, eating, mating, all shuts down. I'm going to decrease all of those things. If you can recall that from part 1A and P, or from this, then you know what's going to happen under parasympathetic stimulation. In parasympathetic stimulation, I'm going to have decreased skeletal muscle and brain activity, which means I start flipping all these arrows. I'm going to decrease my heart rate back to baseline, my blood pressure, my breathing rate, the release of glycogen. And actually what's going to happen, and I'm going to decrease blood vessel diameter to my brain, my skeletal muscles, my heart, and my lungs. I'm going to dilate blood vessels going to the digestive tract, because now it's time to refuel, to reload the liver with glucose, eat a meal, make waste, clean the system out, reproduce if you need to, lay down and rest and take a nap and recuperate. So all of the arrows flip once we get to parasympathetic. I think it's a simple concept. I want you guys to really go back and review. If you had my part 1 class, then the very last page of the note set had a little table that you guys could look at and understand sympathetic and parasympathetic function. Okay, so I'm going to come back to these things a number of times this semester, and we're going to fly through it. I'm going to expect you to know it. Okay, there's some definitions that you're going to go back over at some point, like peristalsis. Those are the contractions of the smooth muscle in the digestive tract and the urinary and reproductive tract. We have some peristalsis. In the digestive tract, we have segmentation. We're going to shut all that stuff down. We're going to increase this under sympathetic. Under parasympathetic, we flip-flop. This all shuts down. This all increases. So, now I hope that was a decent review for you. I hope that you understand sympathetic and parasympathetic. I could have carried it out a little bit further and written some more stuff on the board, but we're really running a little bit out of time. You guys can look this information up. You can write out all the things, and I will post a copy of that table in my worksheet. This will not be on your first test, but I want you to review it before we get to the first exam. The very next lecture is going to start with the receptors that I erased over here from the first drawing. So, thanks for watching. I hope you had as much fun as I did. I hope you learned something. I'll see you on the flip side for the next lecture.